Okay, what is work? Work is done whenever the object moves. So, force is applied when you're trying to change an object. Now, if the object actually changes position or changes shape, work is done. Now, how do we calculate or find out in numbers? Well, it's a simple equation. Whenever you have work done, you have two things working on it. First, force, measured by newtons, and then motion done, or a distance that the object has moved. So the equation for work is force multiplied by distance. Well, force is measured by newtons. Distance is measured in meters. The outcome of force divided by distance is called joules, where joules refers to one of the scientists actually that had many contributions in this field. So work done, the joules equals newtons multiplied by meters. For example, if 10 Newton is applied to move a box 2 meters, what is the work done? Basically, 10, which is force applied, 2 meters, which is the distance moved, that will equal 20, or basically 20 joules. Now, if you have work done, what is the power outcome of that work? Well, the power outcome is the rate at which energy is transferred. Now, when you do force, unavoidably you add energy, because without energy, nothing can work. Now, how can we show the efficiency or the difference in one force working on an object and another force working on the same object? Well, we can add that up to have a power. Now, what is power? It's basically work divided on the time done, because basically if you have work done in short time, that's better than work done in a longer time, especially if you're talking about a device that you like to do stuff for you, like for example cut the grass in the garden. You would like it to have more power, i.e. more work done in less time. Now, power is measured by watts, another scientist. And remember, work done we measured in joules, while time is measured in seconds. For example, if you need, there's an electric motors that lift a 2 Newton weight at a 10 meter, which has more power, the one that works in 5 seconds or the one that works in 10 seconds? Well, we apply the equation. We calculate work done, then we divide each one on the time taken. This will have 4 watts. This will have 2 watts. So obviously, this has more power because it can get the job done in less time. A better device than the one doing it in 10 seconds. Like the RAMs for a computer. The more RAMs you have, the better the computer is. Now, elastic force is basically very much like tension. However, with elastic, you have a change of shape. Now, elastic force is a contact force, because for an object to change shape, something has to be acting on it directly. Unless you have superpowers, that's a different story. Now, the change in a shape, we call it deformation. It's a pretty much a geological concept, deformation. Nonetheless, we have 2 kinds of elasticity acting. Now, you are elastic if you go back to your original shape once the force is moved. You are inelastic if you change permanently once the force is moved. For example, a rubber band, you stretch it, and once you move your hands, it goes back to its original shape. Now, playing though, when you change the shape, it basically stays at the shape that you have left it in. So in some way, we call it an elastic force. Or a more easier one, when you apply force on a pencil, it bends a little bit. Now, if you release the pencil, it would go back to its original form. That's elastic. However, if you keep pushing or changing the pencil until it breaks, that's an inelastic behavior, because it basically changed shape permanently, and no, sticking it back with super glue does not count. Now, why are we taking this? Well, basically, because it helps you to recognize changes through a graph. And it's really important in understanding the tendencies of objects to change shape or change permanently or temporarily. Now, and it's very important in geology actually, or very important when you try to build a device and have a certain strength in it. Now, if you look at this graph, it's a very important graph, and it's very important in geology and in building stuff that has certain strength, like for example concrete, choosing the material for a car body, choosing the material for furniture. Often companies will apply this graph. What does it show? Now, at any point at any point of force on the straight line, whenever you release the force, there is the object will go back to its original shape. However, once you exceed the limit of proportionality, which means that the carrying limit of an object, if you apply more force on the object, it no longer can go back to its original shape. It actually will start to change permanently. So if you want to be an engineer and build stuff, this is a very important graph. Why do we study it? Well, to recognize how forces work with a graph. What's the importance of it? It shows you two different behaviors of an object under the same concept, which is extension or elasticity. Here, you are elastic because you can go back to your original shape if the force applied is removed. Here, you are no longer elastic because the force has changed you to a point when you cannot extend anymore. Again, why do we study this as an example of graphs and forces? What is its importance? It shows you two different behaviors under the same force, which is extension. Now, what does it show you? Here you are elastic. Here you are not elastic anymore because the force has changed your property permanently. Now, this is the limit of information you need to know. If you have any questions, please don't hesitate to email me. Thank you.